x sub 1 minus x times x sub 1 minus x sub 0 up to x sub 1 minus x sub n plus up to f of x sub n divided by x sub n minus x times x sub n minus x sub 0 up to x sub n minus x sub n minus 1 is equal to 0. Therefore, this divided difference or n plus 1 divided difference will be equal to negative 1 times f of x sub 0 divided by x sub 0 minus x times x sub 0 minus x sub 1 up to x sub 0 minus x sub n plus f of x sub 1 divided by x sub 1 minus x times x sub 1 minus x sub 0 up to x sub 1 minus x sub n plus up to f of x sub n divided by x sub n minus x times x sub n minus x sub 0 up to x sub n minus x sub n minus 1. And then the result will become x minus x sub 1 times x minus x sub 2 up to x minus x sub n divided by x sub 0 minus x sub 1 up to x sub 0 minus x sub n multiplied by f of x sub 0. So f of x will be the resulting equation. Plus minus x sub 0 times x minus x sub 2 up to x minus x sub n divided by x sub 1 minus x sub 0 times x sub 1 minus x sub 2 up to x sub 1 minus x sub n multiplied by f of x sub 1 plus up to x minus x sub 0 times x minus x sub 1 up to x minus x sub n minus 1 divided by x sub n minus x sub 0 times x sub n minus x sub 1 up to x sub n minus x sub n minus 1 multiplied by f of x sub n. To sum up this part of equation, we have f of x is equal to this value. So this equation or this notation is what we call the Lagrange coefficient, wherein this is equal to L sub I of x and f of x sub I is equal to y sub I. In connection with the derivation that we had earlier, the Lagrange formula is equal to p of x is equal to the summation of L sub I of x times y sub I, where I is equal to 0 up to n, where L sub I of x is the Lagrange multiplier function, and L sub I of x is equal to this expression having the properties L sub I of x sub k is equal to 0, for k is not equal to I, and L sub I of x sub I is equal to 1. Let's have an example using the interpolating polynomial by Lagrange. Find the interpolating polynomial p sub 3 through the points 0, 3, 1, 2, 2, 7, and 4, 59, and then find the approximate value of p sub 3 of 3. The Lagrange coefficients are L sub 0 of x is equal to x minus 1 times x minus 2 times x minus 4 divided by 0 minus 1 times 0 minus 2 times 0 minus 4, which is equal to negative 1/8 multiplied by x raised to 3 minus 7x squared plus 14x minus 8. And then L sub 1 of x would be equal to this expression, which would result to 1/3 multiplied by x cubed minus 6x squared plus 8x. And then L sub 2 of x would be equal to this expression that would result to negative 1/4 multiplied by x cubed minus 5x squared plus 4x. And then L sub 3 of x would be equal to 1/24 multiplied by x cubed minus 3x squared plus 2x. And then p sub 3 of x will be negative 3/8 times x cubed minus 7x squared plus 14x minus 8 plus 2/3 multiplied by x cubed minus 6x squared plus 8x minus 7 over 4 times x cubed minus 5x squared plus 4x plus 59 over 24 multiplied by the quantity x cubed minus 3x squared plus 2x would be equal to 1 over 24 times 24x cubed minus 48x plus 72. And it would result to x cubed minus 2x plus 3. And therefore, p sub 3 of 3 will be equal to 27 minus 6 plus 3, which is equal to 24. The next topic is about Newton's divided difference formulas. Do you know that the person who developed the laws of motion is the same person who invented the Newton's divided difference formula? He is none other than Sir Isaac Newton. Sir Isaac Newton was born on January 4, 1643 at Woolsthorpe by Colsterworth, England. During that time, England has not adopted the Gregorian calendar, so his date of birth was recorded as December 25, 1642. He was born prematurely, and his mother said that he could have fit inside a quart mug, which is approximately 1.1 liters. He was educated at the King's School in Grantham and Trinity College in Cambridge. His contributions in mathematics are solutions to the contemporary problems in analytical geometry of drawing tangents to curves differentiation and defining areas bounded by curves integration. He also had discovered general methods of resolving problems of curvature, and he was the one who generalized binomial theorem and Newton's identities. He was also the person behind Newton's method, and he classified cubic plane curves, the polynomials of degree 3, into variables. He began to develop a mathematical theory that would later become infinitesimal calculus, made substantial contributions to the theory of finite differences, and was the first to use fractional indices and to employ coordinate geometry to derive solutions to Diophantine equations, approximated partial sums of the harmonic series by logarithms, a precursor to Euler's summation formula, and was the first to use power series with confidence and to revert power series. He died on March 31, 1727 at Kensington, Middlesex, England.